On Friday, you received a paper that looked like this, and you taped it in on page 49. If you do not have this sheet taped in on page 49, then you need to see the substitute to get a copy of this. On Friday, we talked a little bit about functions and what it meant to be a function, so we're going to continue looking at that. So we're going to open up, and underneath the first tab, which is your functions tab, you need to write, in order for a relation to be considered a function, each member of the domain X must be paired with only one member of the range Y. Underneath not a function, you need to say, if a member of the domain is paired with more than one value in the range, then it is not a function. So to be a function, you have to have each member in the domain X paired with only one member in the range. To be not a function, a member of your domain is paired with more than one value in the range, and then that means that you do not have a function. So if we look at an example of what is a function, let's say that you have a set of numbers or relation that looks like this. So you've got 4, 6, you've got 7, 2, and you've got 5, 1. For this one, we would say that this is a function, and the reason it is a function, we would say every X is paired with a different Y. So that is basically our requirement for being a function. Every X is paired with a different Y. So if we look at all of our X's here, we would see we had X equals 4, we've got X equals 7, and we've got X equals 5. Because none of those X's repeat, then that means that we do have a function. If you open up your not a function flap underneath ordered pairs, you would have a relation that looks like 8, 3, 9, 5, and 8, 6. And we would say that this one is not a function. The reason that it is not a function is because a member of the domain is paired with more than one member of the range. And so you might want to say X equals 8 is paired with 3 and with 6. And that makes it not a function. All right, underneath tables. So let's go underneath the is a function column underneath tables. So let's say that you have a table that looks like this. So you've got 3, 9, 4, 9, 5, 9, 6, 9, and 7, 9. So for this one, as long as I'm looking at my X column and I see that all the numbers are different, we would say that it is a function. And the reason it is a function is because every X is paired with a different Y. In contrast, if you're underneath is not a function column and you're looking at the table, let's say that you have a table that looks like this. So you've got the point 2, 3, you got the point 4, 6, you got the point 4, 9, then 6, 12, and then 8, 15. So if I'm looking at this, I would look in the X column and I would see that I have 2, 4, 4, 6, and 8. That means that this one is not a function because a member of the domain is paired with more than one member of the range. And so we would say basically that this means that x equals 4 is paired with 6 and 9. And that makes it not a function because I can't have an x value that repeats. Basically, you would say this is not a function because the x value, x equals 4, repeats 2 times. And it can only show up once like it did in this table. All right, so if you go back to where we began, let's say that you're looking at mapping diagrams. So we're going to compare what it looks like to be a function in a mapping diagram and what it means to be not a function in a mapping diagram. So let's say that you have a point, that you have a mapping diagram, let's say that looks like 2, 3, 4, 7, and 6, 11. And let's say that 2 goes to 7, 4 goes to 3, and 6 goes to 11. So remember, this is just another way to write a relation because what I would really end up with in a mapping diagram is the point 2, 7, 4, 3, and 6, 11. So if I'm looking at this, basically I would say this is a function because if I'm looking at the x values, none of them repeat. So this is a function because every x is paired with one y. Or you might say with a different y. All right, so let's say that you had a mapping function that looks like this. So say you've got 2, 3, 4, 7 over here, and then an 11. So let's say that you've got 2 going to 7, and 2 also going to 11, and then 4 going to 3. So remember, this is another way to write a relation. So if the number in the x points to a number in the y, that means that it goes together in an order pair. So 2 points to 7, so I'd have the point 2, 7. 2 also points to 11, so I'd have the point 2, 11. And 4 points to 3, so I would have 4, 3. And so if I'm looking at this one, if I look in the x's, I see that I have x's that repeat right here in the 2's. So we would say this is not a function because a member of the x or the domain is paired with more than one member of the range. And so it might be helpful to know that x equals 2 is paired with 7 and 11. And that's what makes it not a function because your x's repeat. So last, let's compare what it looks like as a graph to be a function and to not be a function. So underneath that, is it a function, the very last flap should be about a graph. So open up that flap and I want you to sketch out a graph that looks similar to this. So this is a graph of a quadratic, which we call a parabola. And for this one, remember on Friday when we talked about is it a function or not? If we were looking at the graph, we still needed to keep in mind that we don't want our y values to repeat. And one way that we did that was we thought about a vertical line. And if I had a vertical line and it passed over the graph, I want to make sure that that vertical line does not cross that graph more than once at a time. So if I was thinking about having a straight line, I would basically be able to run a straight line through here and I would see that it didn't cross more than one time. So for this one, we would say that this is a function because it passes the vertical line test, which is just one of the methods that we can use if we have a graph and we want to make sure that the graph that we have is or is not a function. Underneath the is not a function, if you're looking at a graph, sketch out a graph that looks like this. So it's a graph that's kind of similar. The only difference is it's on its side. And so if we keep in mind our vertical line test, and we're thinking about running a vertical line straight down, if I think about that, I would see that I would cross, like if I were to graph a line that sat on top of that, red graph right here, I would see that it crosses here and it also crosses here. So it crosses 2 times at one time, which means that that would not be a function. So this is not a function because it fails the vertical line test. Remember, the vertical line test is just an easy way for you to see if the y values repeat. If your y values are going to repeat, that means that you're going to have a line, a direct line that you could draw through and cross that graph more than one time. From the substitute today, you should have also gotten a booklet that says evaluating functions on it. So you're going to take this booklet and you're going to put it on page 50. And inside the booklet, we're going to work on evaluating functions. So evaluating functions is an important part of Math 1. When you evaluate a function, you are given the x value, which is used to find the y value. Remember that x and y are not the only letters that can be used. So you can use any letters because x and y are just variables, and we can use any letter that we want to represent a number that we do not know. So if we look at number 1, it asks us to evaluate the following expressions using the functions below. So we see g of x equals negative 3x plus 1, f of x equals x squared plus 7, and h of x equals 12 divided by x. And so on the first part of this question, A, it asks us to find g of 10. So if I look at how this is written, I see that this 10 is in the place of that x right there. What that means is all I'm doing is I'm saying that x is equal to 10. So I'm going to go to g of x, and I go to g of x because it had the g out front. I go to g of x, and where I see an x, anywhere I see an x, I'm going to replace it with 10. So that means that I'm going to have g of 10 equals negative 3 times 10 plus 1. So remember on Friday we talked about how x was the input and how y was the output. But we also talked about how sometimes instead of y, you might see something fancy like f of x, which is what we're seeing here. The only difference is we're not using f, we're using g, but it really doesn't make a difference. So at this point, I've plugged in 10 because it's my input, and now I'm going to get out an output. So I'm going to have g of 10 is equal to negative 3 times 10, which is negative 30, plus 1. So that means that g of 10 is equal to negative 30 plus 1, which would be negative 29. So that means that basically, if I were to graph this g of x equals negative 3x plus 1, one of the points that I would see on that graph is I would see a point that was 10, negative 29. And I get the 10, negative 29 because I took 10, plugged it in, and I got out negative 29. For B, I'm going to do f of 3. So I see that in the place of this x here, I have a 3, which means that I'm going to plug in for my input 3. So I'm going to go to my f of x equals, and anywhere I see an x, replace it with a 3. So I would have f of 3 equals 3 squared plus 7. So I'm inputting 3, and I'm going to get out a number, which is going to be like my y. So I'm going to have f of 3 equals 3 squared, which is 9, plus 7. 9 plus 7 gives me 16, so that means f of 3 equals 16. If I were to graph f of x equals x squared plus 7, one of the points that I would see would be 3, 16. So there's a couple of ways that you might see this answer. You might see it written as a point, or you might just see this f of 3 equals 16. You may also just see 16. Any of those three ways is an appropriate way to answer that question. C says h of negative 2. So for this one, my input is going to be negative 2. And when I plug in negative 2, I would say that h of negative 2 equals 12 divided by negative 2. So my input is negative 2. My output would be whatever 12 divided by negative 2 is. 12 divided by negative 2 would be negative 6. So I could see my answer written like this. I could see it as -6, or I may see it as the point -2, -6, which means that if I were to graph this 12 over x, I would see a point that was -2, -6. J of 7. So if I go back, I can see that j of x is 2x plus 9. So I'm going to write that up here. J of x equals 2x plus 9. And I see that the input that they want me to use is x equals 7. I know that because the 7 is in place of where the x is. So I'm going to take 7 and I'm going to plug it into where I have x. So 2 times 7 plus 9. 2 times 7 gives me 14 plus 9. And so I have j of 7 equals 14 plus 9, and I can keep going and say j of 7 equals 23. I can see it written like this. I can see the answer is just 23, or I may see it written as a point, 723, which means I plug in 7 and I get out 23. For E, I need to find h of a. So I'm going to start with h of x equals, and I'm going to go back here to get that. So that was 12 over x. And this time they're asking me to plug in a as my input. So what that means is x is going to be equal to a. So anywhere I see an x, I'm going to replace it with an a. So h of a is going to be equal to 12 divided by a. And that is just going to be my answer because I can't simplify it anymore. So I may see my answer written as h of a equals 12 over a. I may see it as just 12 over a, or I could also see it written as a point where my input was a, or my x was a, and my y, or my output, was 12 over a. For F, I need to do g of b plus c. So I'm going to go back and figure out what g of x was, and it was given to me as -3x plus 1. And so what this one is asking me to do is this time I'm going to plug in for x b plus c. So that means that x is going to be equal to b plus c. So I do it just the same way that I did something like j of 7 where I plugged in 7. This time I'm just plugging in something that's got 2 terms to it. So what that means is anywhere I see an x, I'm going to replace all of x with b plus c. So I'm going to say g of b plus c equals -3 times b plus c plus 1. In order for me to figure out what that would be equal to, I'd need to take this -3 and distribute it to everything inside, which means I would have -3b minus 3c plus 1. And because I can't simplify that down anymore, my answer would be g of b plus c equals -3b minus 3c plus 1. Typically, I would say they would not write this answer as a coordinate as we have the other ones, just because it's kind of messy looking, but it's possible that you could see it written that way. So you would see something like b plus c as my input and -3b minus 3c plus 1 as my output. All right, so on G, H, and I, we're going to kind of be going backwards a little bit. So it asks us to find x if g of x is equal to 16. So I'm going to go back to the beginning so that I have my g of x equals and my h of x equals and my f of x equals, just so I know what those were originally equal to and I can see them on this page. So g of x was equal to -3x plus 1. And h of x was equal to 12 over x. You guys don't have to worry about this because you've already got it on your page. And f of x was equal to x squared plus 7. So what this is telling me now is that I need to find x if g of x is equal to 16. So what I'm going to do is I'm going to go back to my original problem and I'm going to replace g of x with 16. So I'm going to have 16 equals negative 3x plus 1. And what they're asking me to do is basically just solve this and get x to be by itself. So the first thing I'm going to do to try to get this x to be by itself is get rid of this plus 1. So I'm going to subtract 1 from both sides. That's going to give me 15 equals negative 3x. And then to get x by itself, I would divide both sides by negative 3. And when I do that, those cancel. And I would have 15 divided by negative 3, which is negative 5, equals x. So basically, in order for them to get an output of 16, they had to input negative 5. I'm going to do h very similarly to how I did g. So it asked me to find x if h of x equals negative 2. So what that means is I'm going to go to h of x, and where I see h of x, I'm going to replace it with negative 2. So I'm going to have negative 2 equals 12 divided by x. Now I want to try to get x to be by itself, but right now x is in the bottom of the fraction, which means I'm going to need to multiply both sides of that fraction by x so that I can get rid of the fraction. When I do that, those x's will cancel, and I'll have x times negative 2, which is negative 2x, equals 12. Then I want to get x to be by itself. So I'm going to divide both sides by negative 2. And when I do that, those cancel. I get x equals 12 divided by negative 2, which is negative 6. I ask us to find x if f of x is equal to 23. So just like on the other ones, because it gave me what the output would be equal to, I'm going to go back to the original, and I'm going to replace the output with 23. So I'm going to have 23 equals x squared plus 7. My goal is to try to figure out what x would be equal to. So I'm going to start by subtracting 7 from both sides. When I do 23 minus 7, I get 16. So that means I have 16 equals x squared. Now my goal is to try to get x to be by itself, so I need to get rid of the squared. In order to get rid of the squared, I'm going to square root both sides. When I do that, that will give me x by itself because the squared and the square root will cancel each other out. Remember, when you take the square root of both sides, you should always put a plus and a minus. The reason that is because I could have a positive answer and I could also have a negative answer. Anytime I take the square root of both sides, I need to make sure that I keep that plus or minus, unless it doesn't make sense to use a plus and a minus. Like if you were finding a measurement, you don't never have a negative measurement, so I don't have to worry about that one. All right, so then I take the square root of 16. 16 is a perfect square, and the answer to that would be 4. So I would have x equals plus or minus 4, which means that x is either positive 4 or x could be negative 4. The reason that I have to have that is because if I'm thinking about some number squared equals 16, I could say 4 squared would be 4 times 4, which gives me 16, or negative 4 squared would be negative 4 times negative 4. A negative times a negative makes a positive, and 4 times 4 gives me 16. Number 2, ask us to change the following statements into coordinate points and then plot them. So if I'm looking at A, I see f of negative 1 equals 1. So remember that the number that's inside the parentheses with the f or the g or the h or the j or whatever it is that your problem says is always going to be your input. So that means that our input was negative 1, and whatever we have it equal to is our output. So our output, of course, is our y. And if I'm looking at that, y would be equal to 1, which means that our point for that would be negative 1, 1. So for A, we would go over negative 1, we would go up 1, and we would put a point. B is done the same way. So we have f of 2 equals 7. What that means is we plugged in 2 and we got out 7, which means we have a point 2, 7. So we would go over 2, go up to 7, 1, 2, 3, 4, 5, 6, 7, and put a point. For C, same thing. So we've got f of 1 equals negative 1, which means we plugged in 1, we got out negative 1, so our input was 1, our output was negative 1. So to plot that one, go over 1, go down 1, and put a point. And then D, f of 3 equals 0, so we plug in 3, we get out 0, which makes the point 3, 0. So we go over 3, don't go up any, put a point, and we're finished. Number 3 asks us, given this graph of the function f of x, find, and then we need to locate each of those coordinates on our graph. So we've got f of -4. So remember that the number in the parentheses is just like our x. So what that means is we want to find x equals -4. So to find x equals -4, we would go on the x-axis, we would locate -4, and then we would find what's happening at the graph at x equals -4. So on the x-axis, go over to -4, which is here, and follow it up to where the graph is. That's right there. So what that means is, if we were to plug in -4, we would get out this point here. If I'm looking at where that's located on the y-axis, it's located at +2, which means that my answer would be f of -4 equals +2. So if I was going backwards like I did in the last problem, that would mean that I had the point -4, 2. So if I wanted to check that, I would see that if I go over -4, go up 2, and so that would be correct. F of 0 means that I have an x equal to 0. So I would go on the x-axis to 0, not move up or down any, and that would be right there. So on the graph, I would be at 0 on the y-axis. For C, I have f of 3. So that means I'm looking on the x-axis at 3. Following it to where the graph is, which is right here. And it looks like we're almost to -2, but not quite. So we could estimate that to maybe be at like -1.8. And that's purely an estimate. We can see that it's definitely past -1, not quite to -2, so I just estimated that it maybe is like -1.8. D says f of -5. So that means that I'm looking at x equals -5. So I'm going to go on the x-axis to where I have -5 and see what's happening on the graph. So if I see that the graph is right here, that means that our output or our y value must be 0 because we have the point -5, 0. E and F ask us to do something a little different. So now we're going to try to find what is x when f of x equals -2. So basically, this f of x is a fancy way to say y. So when y equals -2. So if I'm thinking about y equals -2, I'm looking at the y-axis, and I'm going to -2 on the y-axis and following it over to where I have part of the graph. So if I'm at -2, I can see that I have a graph here. And so basically, I would just follow that up on the x-axis and see that it's at +2. So x would have to be equal to +2. That would create the point to -2, which is where I have that point on the graph. F says x when f of x is equal to 0. Remember, this is a fancy way to say y. So if I'm looking on the y-axis at 0, what is the x value that goes with it? And so for this one, x would also have to be equal to 0 because I have a point right here at the origin. That means that on the graph, I would have a point 0, 0. Number 4 says, swine flu is attacking the North Pole. The function below determines how many elves have swine flu, where t equals time in days and s equals the number of people in thousands. So then they give you this function, s of t equals 9t minus 4, and they want you to find s of 4. So that means that I'm plugging in 4 for t, because the 4 is in the parentheses where the t is. So that means that I would do 9 times 4 minus 4. 9 times 4 gives me 36 minus 4, which gives me 32. So then B says, what does S of 4 mean? So what that means is I have plugged in 4 for T. T was the time in days. And S of T, or S, would be the number of people in thousands. So what that means is if I plugged in 4 for T, that after 4 days, there are 32,000 sick elves. And I know it's 32,000 because my output was 32 for S, and that represented the number of people in thousands. C asks us to find T when S of T is equal to 23. So now we know that our output is 23. So I'm going to go back to this. S of T equals 9T minus 4. This is for C. And I'm plugging in 23 for S of T. So 23 equals 9T minus 4. So I'm adding 4 to both sides because my goal is to try to solve for T. And when I do that, that cancels. 23 plus 4 gives me 27 equals 9T. Divide both sides by 9. And I get 27 divided by 9 is 3. So 3 equals T. What does S of T equals 23 mean? So what that means is after 3 days, because my T was equal to 3, there are 23,000 sick elves. And I know that there has to be 23,000 sick elves because I have an output equal to 23, which is my S, and that's the number of people in thousands. So if there's 23, that means there's 23,000. E asks us to graph the function. So if we need to graph the function, we need to look at how it originally looks. So if I see 9T minus 4, that kind of looks like Y equals MX plus B. The only difference is instead of using Y, they use S of T, which we know is a fancy way to say Y. And instead of using X, they use T, but that really doesn't change anything either. So if I'm looking at how it's written, I can see that I have a slope, which is M, equal to 9 because it's in front of the variable. And then I have a y-intercept equal to negative 4. So if I go to graph this, I'm going to start at negative 4. 1, 2, 3, 4 on the y-axis, put a point. And to get my next point, I'm going to go up 9 and over 1 because that 9 is really a fraction 9 over 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1. So once I do that a couple of times and have several points, then I can connect them with a line that has arrows at the ends. And this would be my function S of T. Evaluate each function at the indicated value. So for number 1, you have f of a equals 3a squared minus 6a plus 1 at f of 2. So what you would need to do for that is it gives you what you want to plug in, and you are eventually going to figure out what is f of 2. So your input this time is going to be when a equals 2, and I use a because that's what they use throughout the problem. So I'm going to do f of 2 equals, and everywhere I see an a, replace it with 2. So 3 times 2 squared minus 6 times 2 plus 1. So if I'm working through this, I'm going to start using my PEMDAS by looking at my parentheses. And in my parentheses, I just have one number, so I can't really do anything with that. Then I'm going to move on to my exponents. So I see that I have an exponent on the 2, so that would be 3 times 2 squared, which is 4, minus 6 times 2 plus 1. Move on to multiply and divide, left and right, whichever one comes first. So 3 times 4 gives me 12. Negative 6 times 2 gives me negative 12. And then I'm adding 1. Then I'm doing add or subtract, whichever one comes first, left to right. So 12 minus 12 is 0, plus 1, which gives me 1. So my answer is I could say either 1 or f of 2 equals 1, or I may see it as a 0.21, which means I plugged in 2 and I got out 1. For number 2, g of e equals 4e minus 1 at g of negative 3. So for this one, it means that I'm plugging in for e negative 3 because the negative 3 is in the place of where e is. So I'm doing g of negative 3 equals 4 times negative 3 minus 1. So PEMDAS again, start with parentheses, but I don't have anything in parentheses that I can use. E is for exponents. I don't have any exponents. M and D can be interchanged depending on whichever one comes first. So I see 4 times negative 3, which is negative 12, minus 1. And then I do add or subtract whichever comes first. So negative 12 minus 1 gives me negative 13. So g of negative 3 equals negative 13. I could see it like that. I could see it just as negative 13, or I may see it as a coordinate, negative 3, negative 13, which means I plugged in negative 3 and I got out negative 13. Number 3 says h of t equals 5 times 4 to the t, where I have h of 3. So I'm doing t is equal to 3, and I'm plugging in 3 for all of my t's. So I'm going to have h of 3 equals 5 times 4 to the third. So I go PEMDAS, parentheses, can't do anything with those, and then exponents are 3. So I'm doing 4 to the third power, which would be 5 times 4 times 4 times 4. 4 times 4 gives me 16 times 4. And 16 times 4 would give me 64. So I would do 5 times 64. So 64 times 5 would be 20, carry a 2. 6 times 5 will be 30, plus 2 more would be 32. So I would have 320 as my answer. I could see it as 320, or I could see it as 320, or I may see it as h of 3 equals 320. And then for number 4, let's do f of x equals negative x squared plus 2x minus 1 at f of negative 1. So if I plug that in, that means that for x I'm plugging in negative 1. So I would have f of negative 1 equals negative 1 squared plus 2 times negative 1 plus or minus 1 actually. So I would start with parentheses. In the parentheses, I can't really do anything, so I move on to exponents. So I've got negative 1 squared, which is just going to be negative 1 times negative 1 plus 2 times negative 1 minus 1. So then in my parentheses, I have negative 1 times negative 1, which is positive 1. Then I've got 2 times negative 1, which makes negative 2 minus 1. This would make negative 1 minus 2 minus 1. Go left to right, so negative 1 minus 2 is negative 3 minus 1, which gives me negative 4. So I could see my answer as negative 4, or you might see it as f of negative 1 equals negative 4, or you also could see it written as a coordinate negative 1, negative 4. We need to use the graph to evaluate the function at the indicated value for 5 and 6. So on 5 it says find f of -2. So for this one, if I look at the way it's written, that means that I have x equal to -2. So on the x-axis, I go to -2 and find out what's happening on my graph. So that would be the point up here, and that would be equal to 4, my y value. Six asks us to find f of 4. So again, I'm looking for where x is equal to whatever the number is in there, which is 4. So I go on the x-axis to 4 and follow it up to the graph, which would be right here. And so that answer, if I match it up to where the y is, would also be 4.